And I saw this question on YouTube and find this integral, no by parts, and I'm not using Feynman trick, so I just find other ways than these two. Okay, now, well, this integral is actually the area well, under this log of y is equal to log x. So this area is under this curve, which is negative uh, from uh, from 0 to 1, and the region is not closed. So this is improper integration, but it's a convergent. Now, well, this integral is actually, we consider the area under this curve, right, from 0 to 1. If we consider this as dx, the width of this slice is a dx. The height, the length of this one is a 0 minus, this is 0, right? This location, this coordinate of y is this. This is a y location, y coordinate. That is y coordinate. The difference is the length of this slice. And then multiply by the width. The width is dx. And we take the summation of infinite many slices in this interval, or in this region, right? There's an infinite many slices like this. So this is take sum from 0 to 1. See, that means is the area we're looking for. Okay, that is one way we find area. Now we can do the other way. What this is y equal to log x. This is 1. This is 0. This is infinity. This is the region. This is the region, the area we're looking for. Now we can consider this region, the area is composed by infinite many slices, but this time is horizontal. Horizontal. So this location is x. This location x is 0. Right? So this coordinate is x. This x is coming from this function, so x is equal to e to the y. So the length of this slice is e to the y minus 0. This is 0. This is e to y. This e to the power of y. This is 0. So that is the length of the slice. The thickness, the width is dy. See, this width is dy. Then we take sum. We add up infinite many slices like this. Infinite many, but they are varying, right? The variable is y, and y is from infinity, negative infinity to 0. So that is the area. This area is equal to that area, same area, right? So, but this area we can do easily. This is equal to e to the y from negative infinity to 0. That is equal to 1. Okay, that means this piece of this area of a region is 1, and so is this. Okay, so this means a equal to 1. So which means integral 0 to 1 log x dx is equal to negative 1. See, it's done. Yeah, the area is below the x-axis, so the area is negative. Okay, but if we consider that way, this is to the right of y-axis is positive. Now that is one way, and we can do the other way. The other way is this. Well, this is a coordinate system, and this is y equal to log x, and this is a piece of area, piece of a region we are looking for. That area is this. So 1 this is 0. Now we can consider that the inverse function of this log function, that is equal to the exponential, right? Yeah, that this function is y equal to e to the x. This is the inverse function of that function, right? They're inverse each other. This is 1. Is it by symmetry? By symmetry, see, this piece is equal to that piece. Okay, my sketch is not very good, but they are similar. They are same. The same region, right? This piece is equal to that piece by symmetry. Therefore, instead of doing this integral for this area, which is this, we can do that area by that function, right? For this area under this curve, this is e to the x dx, right? X is from infinity minus infinity to 0. So instead of calculating this one, we are calculating that one. But this area is positive. This area is negative. We refer to the x-axis. Yeah? Above x-axis is positive. Below x-axis is negative. So in other words, this is equal to negative of that. This is negative of that area, right? But the same value, but opposite sign. So this one's a negative e to the x from minus infinity to 0. It's negative 1. So we found that one. No, we didn't use a Feynman trick. We didn't use by parts. Well, I hope that explains. And thank you for watching.